In this video this is the first video in a series on factoring unknowns. Although in this video we're going to be factoring knowns just to get the concept down and practice how to do it. And then in the next couple of videos we'll be going over the more difficult questions. Also in this video we'll go over these particular concepts and show how they're interchangeable. So question number 1 asks, is 14 a factor of 62? So first of all, this is the same question as, is 462 a multiple of 14? Or is 462 divisible by 14? It's helpful to understand that. And it's really just asking, does 14 divide into 462 without a remainder? So we could, for example, do this question by long division. You can go 14 into 462. But let me show you a different method that is going to be helpful for the more tricky questions later on. The first thing we're going to do is we're going to prime factor both of these. So 462 can be broken down into 2 times 231. And 231 is a multiple of 3 because 2 plus 3 plus 1 is 6. And when the digits add up to a multiple of 3, the entire number is a multiple of 3. So this is 3 and 77, and then 77 is 7 and 11. And 14 breaks down into 2 and 7. So what we have is 462, which equals 2 times 3 times 7 times 11. And what do we have? 14, which equals 2 times 7. So the question is 14 a factor of 462? What's important to recognize is what they're actually asking is, do the components of 462, that is the prime factors, allow us to create 14? In other words, out of the prime factors of 462, can I find the prime factors of 14? All of the prime factors. And I can. There's a 2 over here, and there's a 7 over here. So the prime factors of 14 can be found in the prime factors of 462, which means that if we wanted to, we can combine the 2 and the 7 into a 14, and that shows us that 14 is a factor of 462. So the key takeaway, just to repeat, is that in questions like this, is 14 a factor of 462? Is 462 a multiple of 14? Is it divisible by 14? Is you want to prime factor and see whether the prime factors in the smaller number occur in the larger number, and that way that tells you that it is a factor of it. Let's take a look at question number 2. Question number 2 asks, is 18 a factor of 462? So we can, you can think of it as, is 462 a multiple of 18? Is 462 divisible by 18? I'll do this one in blue just to differentiate it. So, oh, by the way, the answer obviously above here is yes. Now for question number 2, let's prime factor. We already have 462 prime factored. So 18 is 2 times 9, or 2 times 3 times 3. So once again, 462 is equal to 2 times 3 times 7 times 11. And 18 is equal to 2 times 3 times 3. And so when we're asking whether 18 is a factor of 462, we're asking whether out of all of these prime factors of 462, can we make 18? Can we find the prime factors of 18? In other words, do we have a 2, a 3, and a 3? Well, we have a 2, and we have a 3, but we don't have any more 3s. So we cannot, out of the prime factors of 462, make 18. We don't have all of the prime factors of 18. And so therefore, 18 is not a factor of 462. Let's take a look at question number 3. And for this, I'm going to have to create a little space by erasing this. Let's take a look at this one. So is 210 a multiple of 26? Same as, is 26 a factor of 210? Is 210 divisible by 26? We'll prime factor this first. This is 210, and this is 21, and this is 10. This is 3 times 7, and this is 2 times 5. 26 is 2 times 13. And so 210 equals 2 times 3 times 5 times 7. 26 equals 2 times 13. It helps to write the primes in order because it's easier to compare that way. And so Is 26 a factor of 210? Well, there's a 2 in both of them, so we know that we can make part of 26, but there's no 13 anywhere here. We're missing the 13. And so the prime factors of 210 cannot be used to make 26 because we're missing that 13. We don't have a 2 and a 13. Therefore, the answer here also is no. Let's take a look at the last question. Let me erase this. We're asked, is 19 times 20 times 21 divisible by 12? Is this entire thing a multiple of 12? Is 12 a factor of this entire thing? So we start with 19 times 20 times 21. Now you may be tempted to multiply these, but since you're going to be prime factoring them anyway, there's no need to multiply and then factor. We can just prime factor right away. So this is 2 times 20 is 2 times 10, and 10 is 2 times 5. And 19, by the way, is already prime. I'm just going to circle primes in this case because there's going to be a bunch of them. And then 21 is 3 times 7. And so 19 times 20 times 21, whatever that number is, actually breaks down to 2 times 2 times 3 times 5 times 7 times 19. 12 is 2 and 6 is 2 times 3, so the prime factors are of 12 are 2 times 2 times 3. And so is 12 a factor of this big number over here? It is, because all of the prime factors of 12, 2, 2, and 3 occur up here. In other words, we can take a 2 from here, that corresponds to that one, this 2 over here, and this 3, to show that if we combine these, we'll get 12, and therefore 12 is a prime factor, is a factor of 19 times 20 times 21. So the answer here is yes. So just to repeat, when you see questions of multiple of factor of divisible by, they're often talking about the same thing, and it's helpful to find the prime factors. This is going to be helpful in the next couple of videos.